This is a quick intro to our about our special speakers from VMware tonight. Cora Iberclyde. She's a developer advocate at VMware. She helps developers and enterprises navigate and adopt modern practices and technologies. And she specializes in Spring, Cloud Foundry, Kubernetes, Tanzu, and modern CI/CD. And then we have our other speaker is Maria Gabriela Brody, and we call her by the name Gabby. She's a solution engineer at VMware. She has many years of experience in software development and operations, and she specializes in new tools, emerging technologies, and modern design and implementation patterns. So with that, I'll hand the microphone over to both of you, Cora and Gabby, and welcome again.
So, all right. Yeah, so thanks for joining us today. We're really thrilled and honored to have this opportunity to be part of the CJUG family for tonight. So we have this talk that we'd like to share on production-like integration testing for distributed containerized applications. And that's the abstract, but essentially it should be clear as we're going through the talk. So the agenda that we have is a little bit of an intro into what we're talking about, and specifically, concretely, we're talking about test containers. So we'll do sort of a introduction of ideas, and then we'll talk about test containers more specifically. If test containers are new, and if you want in the chat, if you want to let us know if you are using test containers, if you have used them, if you're expert, beginner, heard of them, whatever your experience is, let us know where you're coming from. And then we'll explain kind of how they fit into your testing lifecycle. And then we'll talk about a few specific perspectives in terms of database integration testing, network affinity, and environment parity as you move from your development environment into your production. And then we'll wrap it up with some takeaways. So that's the general idea. So what do we really mean by production-like integration testing? Nice. Thanks for so you've been using test containers for a while for databases and JDBC. Cool. So production-like integration testing, what do we mean? So really we're focused, there's a lot of different kinds of tests, right? But we're really focusing on integration testing, right? The points where your system, your application talks to other things outside of itself. And the goal is to really have the greatest fidelity possible when you're testing as far left as possible. So like on your laptop, right? On your local computer, you want the greatest fidelity to the conditions that you're going to expect in production in terms of the type of system, in terms of the network reliability, the OS environment, everything. And yeah, the farther left you can shift that, obviously, the cheaper it is in terms of time, effort, money to fix problems, right? You catch them early. So what are some of common approaches that we've seen to integration testing over the years? So one is to have a shared instance, right? If somebody installs or your company has an instance that everybody knows about, everybody has connection information to, and you all just kind of use that. Or sometimes people prefer to have a little bit more control, and so they'll install something locally. Like I certainly remember you were talking about Sun and Oracle. That was actually my job history. I worked for Sun, was purchased by Oracle, and but I remember many times installing like Oracle XC on my machine. So I would have my own database to work with just to make my life a little bit more, have more control. But that's a lot of toil. And so then in-memory solutions became an option at a certain point, right? Having something like H2 or HSQL, where it just kind of starts up in the memory of your process. And it's very convenient, right? Each one of these is a step forward in terms of convenience to the developer working locally. So in terms of that kind of in-memory testing, right, the most convenient of those three options, it really means that you have something running in the memory of your application. And that could be something like a mock server, like WireMock, so you have an HTTP server or something running locally, or it could be some kind of in-memory, like a database service or something like that, right? But it just starts in memory. But while this is convenient, it has some limitations, right? Number one, it requires framework support. So if you're working in Java versus Python versus something else, you're going to have different options available to you, right? Some languages will support this more than others. And even though you have the facility of like the general behavior locally, the in-memory service is probably going to be sort of like a poor man's version of the thing that's running in production, right? There's going to be differences in behavior. And there's certain things that are harder to test, like latency, bandwidth testing. It's hard to test that when you have some of these in memory, like HTTP service, for example, will give you some ability to test some networking things, but you're not necessarily going to have all of the options that that might represent the glitches that you might encounter in production. And then not every service has an in-memory option, right? There's a lot of different types of services that we need to talk to that you're still going to be stuck either installing your own or using a shared one. And then there's just differences in configuration that you may not account for, right? So as you move forward in environments, you may find yourself finding misconfigurations as you move forward. So what's happened is that as we've moved from monoliths to microservices in this world of containerization, these challenges really just become exacerbated because now we have more applications because there's microservices, and that also means that there's more connections between things, there are more points to test. And then there's also a variety of service options that have increased over the last 10 years. Like if you just look at like the CNCF landscape, right? These are more familiar. These are the more common ones you might encounter, but like there's been an explosion of NoSQL databases, for example, right? That you can choose, or just message queues, choosing the right tool for the right job often lands you in a place where you have a bigger variety of things that you're working with. So this is just like, you know, that can get overwhelming. There's a lot of choices and they don't all have in-memory options. So containerization in general has helped this problem, right? If you can start something up as a Docker container on your local Docker daemon, then that's really helpful, right? At least you're not installing all these things locally and maintaining them on your machine. And then something like a Docker Compose can be really useful because it can start different containers at once, right? So it also makes your sort of the administrative job around managing these systems that you have to test against easier, but it's still not as easy as it could be, right? It's still, even with Docker Compose, or if you're just working with containers directly, there's still a lifecycle management that responsibility falls on you, both from just like sort of regular toil that you're going through, and also it's an additional skill set for developers to learn. And I think that, you know, as the years go by and more people are familiar with containers, like that skill set becomes a little bit broader, but it's still a new skill set for a lot of people. So good news is that there's actually an easier solution. So that's what brings us to Testcontainers. So this is, Testcontainers is a library that basically is part of your application that manages the life cycle of anything that you can containerize, and it runs it on Docker outside of your application. So suddenly all of that toil and lifecycle management is delegated to this library, and you can test against anything that can be containerized. So it's pretty powerful. So a little 101, I'm going to check, is there anything in chat? I think we're good, right? Okay, cool. So I'll do a quick intro for those for whom Testcontainers is new. I think this will be useful. So Testcontainers for Java is a Java library, and it creates instances of Docker containers for testing, and it supports JUnit 4, JUnit 5, and Spock. So there is Testcontainers for other languages. So if you are interested in using this and you're working with other languages, definitely go check out their GitHub site, and you can find other options. I think Java is the oldest and the most mature, but there's definitely other options and they're usable. If you look on their website, you'll notice that they have a list of modules that are readily available. So these are things that are, some of the configuration has been done. You have default containers, so they're very easy to work with. So you can see in the sort of the center column, I don't know if you can see my mouse, but here there's a bunch of different common use cases. And then under databases specifically, there's a whole sublist. There's generic things like JDBC and R2DBC, so you can really work with anything. And there's also specific database flavors. But you don't have to use any of these out of the box kind of configured, shortcuts or facilities. If you can containerize something, if you can anything, you can actually start with a Dockerfile. Anything that can be containerized can be used with Testcontainers. So where would you use these, right? So, and why would you use these? So the point of using a test container versus an in-memory option is that the test container gives you it has the potential of giving you a much greater affinity to a production-like system, right? So if you're working with HSQL or H2 and you're working with Postgres in production, there's going to be a bigger gap between those than if you actually use a Postgres container running on Docker on your machine to test against, right? And then you can test against any application that can run as a container. So you're not working within the limitations that I mentioned, right? Of what's supported by your framework or what's, what has an in-memory option versus not, et cetera. And so really, it really is useful for anything where you're testing an interaction between two different components, right? So it's data access, or it could be an application integration, or they also support something like a Selenium testing, browser-based acceptance testing. Test containers can also be used for that. Just a little, where did it all come from? Where did it all start? There was a gist by someone named Moshe Eshel, Docker container rule.java. This is the inspiration, and you can see that within, I forget exactly what the time difference is between the gist and November of 2017, but there's a comment in the gist that says basically this has been superseded by test containers. But this was the inspiration, and this was really just a JUnit 4 rule that could be used to manage the life cycle of a container. So that integration with JUnit, the integration with JUnit 4 was a little bit more tightly coupled. And the integration and then for JUnit 5, there was kind of like a rewrite a little bit of that integration. And so with JUnit 4, you just use @rule or @class rule to annotate your test class. But with JUnit 5, there is this extension, this JUnit 5 extension that intercepts the JUnit lifecycle events and to manage the container lifecycle. So if you have your own test class, you would annotate it with @Testcontainers, and that would extend that JUnit, that would include that JUnit extension. And then on the actual object that is that represents your container, then you would annotate that with @container, and that way you're telling test containers, hey, this is the object that I want you to lifecycle manage. And so again, this would be like in JUnit 4, you would use rules and class rules. So then these are, if you are familiar with JUnit, these are the lifecycle callbacks that you can use in your code before tests or after tests, after each or after all of them, et cetera. So I just wanted to quickly walk through kind of like, if you have a test class that just leverages all of the lifecycle events, right? So you can see in the annotation in yellow, right? Before all the tests log this is just logging a line, right? So before all of them do this, after all the tests have finished, run this. And then what to do for each test. We have 2 tests in this example. And then before each specific test, do something. And after each specific test, do something. So really just like logging something to the log file just to mark the steps in the life cycle of JUnit. And what I want to show you is what is the output of the log to see where is it that test containers are actually being instructed to do something, right? So first of all, before all the tests are run, whatever your code is for before all, that's what runs. Test containers is not doing anything yet. And then you get to the constructor of the class. So again, just a class instance is created. Test containers have not yet done anything. And then when you get to the before each test, so before your code is run, before this line is logged from the actual method itself, that's when test containers says, oh, I have to do something before this code can run. And so if it's the first time that test containers are doing something, then they're actually going to validate that the Docker environment is up and running and okay. So they look and they say, okay, Docker is here. I've connected to Docker. Everything is okay. And then the way test containers work is that they actually pull in a container called Reuk. And that container is responsible for shutting down and cleaning up after your tests have run. So first it does a Docker pull. And again, it's validating all Docker. And then it says, okay, well, what is the container that the developer wants to test against? So it does a pull of that. So my repo, my image is just up here on the left. This is the one that has been annotated with @container. So here we've told this class, we've annotated it with the class annotation to have the extensions for the callbacks. And then we've also said, hey, this container is what we want. And the container image is on Docker Hub, and it's in a library called my repo, and it's my image. So it goes ahead and pulls the container that we need to test against, and then it starts it up, right? So this ID that you see, this long unique ID number, is the instance of that process that it started up. So when we log our before all, we can see that we have a certain class instance ID, and then we have a certain container ID. So now there's a container. Now our before each can run. So maybe we do some prep work inside the container. It's a database, maybe we need to populate something. Then our test would run. Testcontainers is not doing anything here, right? It's just provided a container for us. So we do our own testing. And then after each code completes, then after that, so we've finished everything we want to do for that test. Now that cleanup container that it had downloaded earlier, that comes into the picture, and it cleans up. It basically deletes that container that you were testing against for test number 1. So for test number 2, you're going to start fresh. So for test number 2, again, we're going through the constructor again, different class instance, and then it gets to the before each. So here it's saying, okay, well, I cleaned up the last container that test 1 ran against, so I'm going to start a new container. Obviously, it doesn't have to do all of the administrative, like, is Docker running, and all these images are already pulled locally, so it's much quicker. It just starts up a new instance of that using that image. And then so you can see that both the class instance number and also the container ID are different in the first test as they are in the second test. Then your test runs, again, no test containers, and then after your after code runs, then again it cleans up that container that you just finished using. And then after that, the code inside of your after all method will run. So that's sort of like where Testcontainers participates in the JUnit lifecycle. Now, if you add the word static, this is the only change in the code from the last picture to this picture. Then the only difference is that the second time when it creates that second class instance, it's going to reuse that container because it's static, right? So then it would be really up to you between tests to do the necessary cleanup before test number 2 runs, right? So that, like, maybe you're going to truncate a table or something like that. But you can do this for the purpose of speed, but it is on you to then clean up that container. Okay, so I'm going to move to. So anyways, just check in with everybody. Like, so far, so good. Or any questions or comments?
Everything okay, I think.
Okay, cool. Thank you. Okay, cool. All right, I'm going to show you a few simple demos. So I will, I'm not going to run these first 2 because it's literally what I showed you in slides, just the life cycle, how it plays into that. And then if you add static, that it just uses that container. But I'm going to show you this one, which is all we've talked about so far is how to start a container, right? So great. So now you're about to run some code, and your code is trying to execute some tests, and the container is running on your Docker daemon, but, like, how do you connect to it, right? How, like, are there credentials? What port is it listening on? Like, how do you actually establish a connection? So, so in this example, again, we've got our annotation for the whole class. We've got our annotation for the container that we want Testcontainers to manage for us. And in this case, I'm just using, this is actually, you can see it resolve on the right. I'm pulling from Docker Hub. There's a container called HTTP bin by somebody named Kenneth Reitz. And this is just something you can just send HTTP requests against this, and it sends you responses. So it's useful for simple testing. And I know from the Docker Hub website that this container, this HTTP bin container, when it starts up, it listens on port 80. And so what I'm telling, I'm adding a parameter here to say, hey, Testcontainers, when you start this container, I need you to expose that, like get me connected to that, that exposed port 80 on the container. Now, this doesn't mean that port 80 on my local host is going to be mapped to port 80 on the computer, on the container, right? But it means that Testcontainers is going to be responsible for exposing a port or mapping a port on my local host that will then be mapped to port 80. So basically there's just two tests here to drive home that point. So in the first test, you can see that we're going to try to make a connection to localhost 80. So based on what I just told you, we would expect this one to fail, right? Because it's not that it's localhost 80, but rather that we're expecting Testcontainers to dynamically map a port locally to port 80 on the machine, on the container. And so in the second one, in the second test, we're going to dynamically inquire from the container, hey, you know, this one is the most important one. Container, get me that first mapped port that you generated and send a request there. And so we're expecting the second one to work. So I will run this just to show you. And then actually, let me do it this way. If we can start, we'll do a watch Docker images. And I don't know if this is going to be easy to read, but watch Docker processes. So let's just put that up here, let's say. And then let's start this one. And run. So as that's going, so what we know is that, okay, so there it's downloaded React, right? And so I think it should have it started, it started React. So there's our cleanup container that's downloaded and running. Now the next thing it should do is actually download the container we want to test against. So we should see, we can see actually the log, it's pulling it layer by layer on the bottom. So we should see it pop up on the top. Okay, there it is. It's downloaded it. So then it should run it and then it disappears. And that I went too quickly. So I ran both tests. So that's, so you can see kind of that in the background. And then here, the results are just what we expected. There is no localhost 80, so that doesn't work. But if we dynamically inquire, it turns out that it mapped port 55012 to port 80 on the container. And so this one will work and we get a response back from the container. So that's how you connect. And that works for, you know, not just ports, but whatever connection information you need. The next one I want to show you is a Dockerfile example. So let's say you want to test against something and that thing doesn't have a ready container, right? It's not something like a Mongo or something else. It's actually, or maybe you want to run tests against your own containerized application, right? So, something that you can build with a Dockerfile. So in this example, we're seeing that we're using, again, this generic container type to create a new image from Dockerfile. And here we're saying, this is what I want you to name the image that you're going to build with a Dockerfile. My Dockerfile is located in this directory. So you can see I have this variable that points to temp/hello world. So just to show you, right here, I have a temp folder, this one, and then hello world is here. And in hello world is not only my source code, but also a Dockerfile. And this Dockerfile, for example, is going to, we're going to see it download both a base image to build the code and then a base image for a runtime image. So we're going to expect these to be pulled, right, as Docker builds the image. And then you can see, like, there's just other parameters that you have control over. You can establish, you can set environment variables for the build and things like that. You can expose more than one port. You can tell it to wait for a certain sort of like a liveness probe, I guess, to make sure the container is ready before you start testing against it. So you have all of these options. And then I'll just show you that to ping from each port, instead of saying get the first mapped port, you can say, for the second one, you can actually say get the port that's mapped to 8081 on the container, right? So we can watch that one. That is this one, Dockerfile. So run this and we'll kind of see the same. So now, of course, it doesn't have to download React, so that part should be a bit faster. And it's not as fast. I think it's, I always blame my machine. My computer can only do so much. Let's see. Okay, so there we go. So now it's doing the build part of the Dockerfile. And it should do the, it should publish our okay, this is moving forward. Okay, so down, okay, there we go. So you can see that it downloaded these two containers in order to run the Dockerfile, and then it published this container, and then it executed tests against it. And if we go to the running processes, we can see that everything has been cleaned up, right? The Riak has stopped the container that we tested against, and it's also stopped itself. So there's nothing actually running. And here you can see that both requests will work, right? Whether we're testing against the first mapped port or the specific port that we requested, both of these tests pass. We're just testing different endpoints. And then another test I wanted to show you is, okay, well, so that's all well and good. We kind of know how to connect a container, so we can see how this can be really useful. So the next question would be like, well, what if I'm testing against a container and something has gone wrong inside of the container? Like, how do I debug that? How do I troubleshoot that, right? How can I see the logs that are actually being emitted by whatever is running inside of the container? So we'll look at container logs. And again, I'm going to show you two ways to do this. So again, same thing. So here we have the test containers annotating the entire class, but actually, if you notice here, we don't have the @container annotating our container object. And because of that, because we want to connect to the logs, we're actually going to manually start the container. So now each of these tests has its own, it's going to lifecycle manage the start. Test containers will still automatically lifecycle manage the cleanup, but because we're not, we didn't annotate this container, then it wouldn't start them by itself if we didn't do the manual start. So in this case, we're saying we're just going to take advantage of this Alpine image. It's the same one that we had downloaded here already for during the Dockerfile. So we'll just reuse that. That's just like a base operating system image. And what we're going to say is that what we want to set an environment variable in this base image called greeting with a value of hello world. And then our application, what we want running when this container starts, we want it to basically echo two lines. One line should be starting up with greeting equals and the value. And the other one should be oops, something went wrong. And we want the oops, something went wrong to be redirected from standard to standard error. So basically we're printing one success message and we're printing one error message intentionally, right? So so the two ways I want to show you to generate logs, actually, let me run this and then I'll explain it. So one way is to just go to the container and just get the logs, and you can either get all the logs or you can get just the things that went to standard out or just the things that went to standard error. You have a choice. So you're going to see this is up here. So we'll look at test number 1. The way that looks in the log is like this. So when we get all the logs, we just get the 2 echo statements. Now, we don't really know that, I mean, because this says oops, we can guess as humans that this is an error, but there's nothing really to indicate here that this was standard error versus standard out. And then you can choose alternatively to get standard out and standard error. So again, so then it does actually, right? Then it qualifies this as info and this is error. And it starts these lines over here on the left-hand side, right? It just kind of dumps the output. So the other choice is to actually take advantage of one of your log consumers and kind of like have the log consumer follow that output. And the way that looks in the log file is like this. So these are actually like inline, the way that you would expect to be really integrated into the output of your logs. and still they are classified correctly as error and info. So this is nice, and this happens like as they're happening.
Cora, I appreciate you using SLF4J to not spark my PTSD from Log4Hell.
You're welcome. That's funny. Okay, so I'm going to do a couple more slides and then kind of one more demo, and then I'll pass it over to Gabby. So, okay, so let's talk a little bit about database integration testing. Is probably like the most common case for using test containers. So this is just that idea, right? That like if you're working with Postgres, like if you're working with something in memory, it's not going to be the same as the thing that's running in production, right? So if you're using H2, even if you set all of the dialects to be like as Postgres-like as it can possibly be, it's still not Postgres. And Postgres is actually what you're going to run with in production. So, all right, so let's do one more test on this. Okay, so I'm going to show you, here's an example of a test that is, so let's say I have in my application, to remember where I put all of this, but okay, this is, so this use case here is that I'm using Flyway, but to run a migration, right? So I would have created some, here's my V1. Where did I put that? I don't know why. It's okay. Here's our V1. This is our basic database table structure. It has an ID, a username, and text. So you can imagine like somebody's creating a message board, right? You want to add a message, you say, hello, my name is Cora, I say hello. But the problem with this message board is that it's getting really full and there's no way to kind of negotiate when a message should be deleted from the message board. So version 2 of our schema, we want to add another column called date of expiration. And for those messages that are already in our message board, we'll just go and we'll set the value of expiration to whatever today's date is plus 1 month. And it just so turns out that this interval syntax is okay for Postgres, but it's not okay for H2, even if you tell H2 to behave like Postgres. So this would be a situation where as a developer, you're writing some SQL and you're like, I know this works with Postgres, but it's not passing my tests. So, it would be better if you didn't have to accommodate your SQL to the limitations of H2, right? So, so we'll watch it fail. Oh, and before I show you this with H2, so you can see here, this is set like everywhere that I could say Postgres, it says Postgres. And then, yeah, so we'll run this test. This is just a regular test, right? No test containers. This is just in memory. So start it up, watch it fail. Yeah, okay, so that didn't run. It doesn't like the syntax, right? It doesn't like SQL failed, blah, blah, blah. Okay, so then instead of that, what would be better would be to use test containers and annotate our container. So here, because there is a Postgres option, otherwise you could use JDBC or however you want to approach this, but there is a Postgres option. So we're going to pull down the Postgres image that's on Docker Hub. And also the other cool thing is that this is also a Spring Boot test. And so we're going to take advantage of this thing called dynamic property sources to actually, so this is the container object, right? So we already saw how we've been able to get ports from the container. Well, you can also get the JDBC URL or the username or the password, right? Because test containers is automatically configuring all of the connection parameters that we need to talk to that system. But we actually, in our Java, we still, if we're Spring Boot developers, we still don't want to deal with these values manually, right? We'd rather just feed them in to these Spring properties. So we can do that using the Spring dynamic property source. So it's all wired together really nicely. And then really we're just expecting, without changing our SQL, just changing the way that we run our test, we would want this to work, because in this case, we're actually testing against Postgres, right? So we'll just watch this one succeed. of course, pulling down that Postgres image. And I'm sure it's almost done. There we go, creating the container, running the test, hopefully. Container is starting. There goes our test. And I mean, you could already see, right, the date of expiration. So it's just cleaning up. And our test succeeded. So that would be a win, right? Don't rewrite your code if you don't need to. So that is all. I'm going to stop sharing and hand it to Gabri. Stop sharing.
Okay, well, Cora, thank you very much. And in the chat, one of the attendees, and I don't want to butcher your name, I think is Suale. He shared that he's currently using exactly for the purpose of testing databases, and it's something that is very convenient because of all the things that we can already see with your demo. Okay, let's go to the next section that is on network reliability. Well, often and mainly when we work in the cloud, we need to have a lot of connection going around between our workloads, and not necessarily these different workloads are co-located, and so there is going to be eventually some piece of network that need to interconnect them. And what can happen when there is a connectivity from point A to point B? Everything is under control, or maybe not, because we know that network it can be sometimes something that changes, like it's not something that we can rely to be always in the same condition. We can have different problem changes in latency, in the bandwidth. There can be connections that are unexpectedly close for many reasons, because lack of connectivity, or simply because the other process failed and eventually is dead. And so now there is no connection over there. There can be changes in packet size. As we traverse from one network to the other one, we can go from 1500 bytes to 9K. The jumbo packet size for the Ethernet. And all of these changes in the characteristic of the network are going to affect the behavior of our application. So how can we do, oops, okay. How can we in some way try to see in an environment that is our local environment, what's going to happen in a more complex situation? Well, there is this framework that's called ToxiProxy that provides an environment where we can easily simulate network condition. Of course, this is something that will help you to modulate some of the parameters, but give you a good understanding of what can be a bad scenario for your application, and test, and eventually already start to remediate before running in a more complex environment and going to the next phase of the test. It's available as a module for Testcontainer, but is also available as a project in GitHub. And Testcontainer, as it is a module in Testcontainer, will start as a separate Docker container, the ToxiProxy application. The ToxiProxy application, the purpose is that you are going to use it to send all of the traffic to and from all of the application that all of the other workloads that your application is connected with through this Toxi proxy, so that depending on what you are configuring in terms of latency, in terms of jitter or changes, any toxic, so any bad configuration, something that's going to decrease the network connectivity, it's going to be simulated through Toxi proxy, and then you can experience these differences in behavior. And the idea is that because of what Cora already showed us, that we have these containers and we are mapping ports on this container, and then Testcontainer will wire all the connectivity through this port on its own. The orchestration will need to happen through the concept of a network. And there is only one network that at this moment Testcontainer is supporting. But the idea is that we have our application run in Testcontainer. There is our service like Postgres in the example that Cora was showing us. We have this network, and we have the Toxi proxy, that is the other container that we are running. And the idea is that all of the traffic will go from our application to Toxi proxy, then down to the network, to the Postgres, and back through the same path. In this way, we are sure that Toxi proxy can apply all the proper cows or Toxi, they are called in the Toxi proxy library, to change the behavior of your network. Now, let's say that you need to use a different container because you have different services, and eventually you want to apply different Toxis to simulate different pieces of the network. You can still do that. The thing is that everything from a perspective of connection, it's still going to be handled by a single network, but you can configure multiple containers that are attached to the same network and the topology that you are interested in testing. So let's take a look at I think actually I didn't share my screen. Okay, this is desktop 3. Okay, so let's take a look of what we have over here.
Deborah, you're not sharing it.
Not sharing yet. Oops. There. Okay. Thank you, Cora. The application, the test that we are having over here is the application that Cora was showing. So we have a microservice that's communicated with the database, and we are going to put a proxy in the middle, and we are going to change the behavior of the proxy to do few things on this connection and verify what happens to the application as we perform our test. So first of all, we are going to create our network. And when we, at this point, are going to start our Postgres database, we are going also to start that in this specific network that we just defined over here, and assign the expose port that we need to use. For the sake of naming, we are going to call this Toxi proxy. We are using the image, the specific tag for the Shopify Toxi proxy container. We are running it in the same network where we were running Postgres, so that now they can be connected. And then we are going to grab the information so that we can, as Cora was showing, configure our application to be able to talk with this database through the proxy. Now, let's see in the first test what we are going to do. So in the first test, this is we are not going to do anything bad to this connection. So the idea is that we are going to run our call to the database to retrieve some of the information. And So everything starts and it's the test run. It's going to retrieve messages from the database, and everything is green. There is only one message over there, and it's properly retrieved, and we are very happy. Now we are starting to play a little bit, for example, with the latency, and we are defining a latency of 1000 milliseconds, so 1 second of latency downstream. We also have the possibility to define the jitter. The jitter will represent the variability of this latency to happen. So like this would be like half of the time. On top of this latency, we are going to add a jitter of 500 milliseconds, so half second, in a variable way. So not necessarily. Usually the latency is 1 second, but sometimes it can be half second or 1 second and a half. So we will have the connection that it's going is not behaving with a reliable and consistent behavior. And we are going to run this test a few times and see if we can actually sustain this type of variability. And the other thing that we're going to do is that we run the first time with this latency of 1 millisecond, of 1 second, and then we are going to increment the latency as we run the test and see if this still behave in the way it should. So what we are doing over here, we run the first time with 1 second, then we are going to change and multiply by 2, and so essentially just increasing a little bit, and we can see with 1 millisecond, then with 1 second, with 2 seconds, with 6, and we see that now it's going to take a little bit more to respond, exactly because we have to wait for the specific time, because we can see that the latency is actually there. But still, our application works really well, so we are very happy about this. Now, let's do another test, and I'm going to start this test because going to take a little bit, but the idea over here is that we want to cut the connection and we want to see what happens if we cut the connection. Now, because I like something that fails gracefully, we are going to say that we are going to cut the connection when we are going to call our URL. And to fail gracefully, we are going to assert that there is an exception that will be delivered by this because the connection has been cut. Then we are going to change and remove this doxy from the connection. So now the connection is not going to be cut. And we are going to do the same thing and verify that if the site is now, the database is now available and we can properly connect to it. And over here, we can see that this is exactly what is happening, because we're going to see over here the exception because of the connection that has been closed. And so we will need to do something over here, circuit breaker, whatever we think is appropriate. And then we run again and it finishes properly because it was also able then to connect on the second call and properly reach the database. So this can be something that is really powerful for our test. It can help us in evaluate some situation that can happen before we actually go in an environment that can be even more complex and work with quite a lot of control on the network parameter that we want to test. Did any of you work? So there was some work done with the database. Did any of you work already with Toxi Proxy before, or is this something new?
Not this component specifically, but more with like Chaos Monkey, the Netflix library.
Okay.
Yeah, but that's not necessarily at like, that's more in the runtime when it's hosted, not maybe necessarily before then, which is kind of better. So I'm all ears.
Okay, let's go to the next thing, the environment affinity. Okay, in the path to production, we want to achieve this parity because if you don't have parity between the environments, what's going to happen is that we are going to do our test, then we are building the application, then the application is going to run. And if we don't know the operating system, the runtime, things can change just because we are not doing the right test. We are not doing the test in the right environment. We should have a different environment to run our test. So how can we have an environment that is as close as possible to the to the production environment? Well, let's see first of all, which are the approach to design this environment, to manage this environment. Usually we have an environment that is the test environment. Then we have the build and the run, and often these are configured separately, eventually even from different teams. And so it's possible that the configuration can be done in a way that is not necessarily always configured. It can be different because of update to the Java version. It can be different to update to any of the different layers that our application is going to use to run. Sometimes, to mitigate this approach, there is the idea of using the two-stage Dockerfile, where we are maintaining control on top of the operating system and what we are running on and how we are composing this environment to do our build. But if we have a lot of application, we need to manage this at scale, managing all of this Dockerfile for all of these different applications can be pretty challenging. So what we are looking at is to use the Cloud Native Buildpack. The idea is that the Buildpack will provide a consistent way to build the images, because it's the builder for your image is distributed as an image itself, and so it's guaranteed to be consistent every time that you are going to use it. It is polyglot, so it can be used across a large number of languages. And you can also invoke this process in many different ways. It can be used through the CLI, through Maven or Gradle plugin. It's something that you can run in Kubernetes. And so really, there are many different mechanisms that we can consume a build through Cloud Native Buildpack. The advantage at this point is that when we use a Cloud Native builder, we know exactly what is the operating system, what is the runtime, and this is going to be true every time that we build the image, and the output is also always controlled. Now, usually when we build using Cloud Native Buildpack, there is a parameter that's used, for example, let's say that we are using Maven to invoke the Cloud Native Buildpack, where we are going to say that we are going to skip the test. And but we can change this. We can say, okay, you know what? I don't want to skip the test. I want to actually execute the test. Now I am in my own machine. I'm using Maven. I can use Buildpack. I can build my application and run the test in this environment and be sure that the image that I'm testing, the environment that I'm using, is going to be exactly the same that I'm going to be using in production, because the full tool chain, it's going to use the same Cloud Native Buildpack. So well, then that's very nice. What should we do? As we were saying, we can run with Maven plugin or using a CLI. The CLI in this case is Pack. And we are going to use Pack build, for example, and give a couple of parameters. So the first one is builder. We are referencing a specific build pack that we want to use. And then we are providing some environment variable. Specifically over here, we are saying which is the test that we want to execute. This is very cool because now we know that in our machine, we can use Docker to do the test and the builder using the Cloud Native Buildpack, and that is super awesome. There is a problem though, that we want to use Docker, and usually the way we are doing this is using the Unix socket to communicate with the Docker daemon. So specifically, we would like to have that our Cloud Native builder running test container can connect to Postgres using Docker, but we don't want to raise privileges for this builder in order to be able to access the Docker socket in our machine, because this is not going to be, we don't want to run with any more privileges than the one that we actually need. And Cloud Native Buildpack will not allow that, because privileges will be dropped, and so it's not going to have any possibility to access the Docker socket. So we have a chance though, because we are talking about socket, we are talking about Unix socket, but we also have the possibility to use a TCP socket, and this will remove the issue that we are seeing over here. So if instead of using Docker host as a Unix path, if we use Docker host as a TCP path, now the guardrail of the Cloud Native Buildpack are respected, and we are empowered to connect with our Postgres, with our Docker daemon and run our Postgres database. So we used a pretty common utility that's called the socket. It's available for Unix, for Linux, for Windows. So and there are anyway also other solutions that are similar to this. Socket at the end of the day means socket cut. So what it does is that streamline the anything that is in the Unix socket in a TCP socket and vice versa. So when we run socket, we are going to run saying, okay, we are going to use this port and connect to this socket. So now when we run our pack command to build the application, we are going to pass the Dockerhost environment variable to tell to Pack how to talk with Docker. And instead of using the Unix socket, we are going to use the TCP socket that we just created over here. And then we can kill socket and go back to our standard operation. So to have a little bit more, actually a lot more of control and pin even more the version, for example, of the JVM, the version of the builder that we are using, we can use a command where all of this is made pretty clear and defined, so that if something changes, we have control on top of this. Let's check how this is going to happen. Let's go to this terminal, and I'm going to run this simple script. The idea is that, let's do it. Okay. So first of all, let's verify that what we said over here. So we run a socket, we run a socket on, this is my IP and on this port, and we see that there is something listening over there. Very nice. Quit. Yes, we can move on. Then let's take a look to our Docker. Okay, so we can see what's happening over there. And then this is going to execute the pack build command. So execute the build and the test running specifically this test package and using the connectivity with the Docker daemon through the TCP connection that we just created. We can see that the test just started, and it's starting now all of the containers that are necessary. We see that now we have one more that is pack, that is the this is the Cloud Native Buildpack also that is executing the container that is performing the build. And we have our Rio container, Toxi proxy, and this Docker entry point.sql. This is our SQL Postgres database that's running in the container. And now we are running through all our tests that we were doing before. We see that we are in the second test where we are increasing the latency. Then we have one more, that is the one where we are the first time cutting the connection and then removing the connection cut and running again the get/messages and verify that this time it's gonna end up properly. So in a moment, we are gonna see that there is an error, and then actually we already see there is the connection has been closed now. Oops. And specifically at this point, we are also, okay. Come on, the timeout, it's a little bit long. So as you can see, it's still, oh, finally. Okay, so it's finished. The build failed because now there was the exception, and now we see that everything is also going to be removed from our Docker. So, takeaways. We can use Testcontainer in general to improve the system affinity between our test environment and the build and run environment of our organization. The Toxi proxy offers a great place to do tests around on networking. And the advantage is that it doesn't have to be only HTTP, because honestly over there, it can be any connection. It can be a plain TCP connection that you can still configure and easily test. Cloud Native Buildpack with Pack CLI and Paketo also provide a way to consume all of this from your local machine and do all the tests that you want to do using Testcontainer. Now, sometimes though, as you start to use eventually a large number of containers, it is possible that the local machine is not necessarily so well equipped. So now, for example, there is an announcement for Testcontainer Cloud that gives the possibility to run your application, to use cloud resources to run your application. And here you can find a little bit of links for what we demoed, our Git repo, information on Testcontainer, Toxi proxy, and Cloud Native Buildpacks. Thank you very much for being here with us.
Thank you. Thank you for the great presentation. I guess at this point, we can have the floor open up for Q&As. Anybody have any questions for Cora and Gabri? And thank you so much too for great presentations. So, let's see if anybody's asking question here.
You did get a comment, Gabri, in chat at Swala says that talks, even though he's been using
okay.
proxy a lot, yeah, or Testcontainers a lot, that it is new for him. So thank you for demonstrating Toxi proxy.
Well, it's a great technology. Yeah, we are very happy that we can use.
I hope everything was clear, because I know that we this presentation can get long, so we tend to like kind of rush through it, but if people are less or more familiar with like build packs or things like that, and you have questions, we're happy to answer anything that you want.
I do have a few questions if we have time. So with regard, and it's on one for each topic. I'll start first with test containers. So, do you have the ability to kind of layer in multiple Docker images to, like, let's say from the marketplace, if you will, you have, a Kafka, for example, module that you would bring in, and then just like a standard like HTTP servlet that might be, serving up just a standard, connection. Would you be able to couple those, or would the approach there to actually be like build your own container that has all of your dependencies that you might need, ranging from, like I have an application that, requires Kafka, requires XYZ dependencies, and just build that bill of materials inside of like a single Docker container? Or would it be like, or would you pass that into the generic container object and just list out all the different dependencies that you would need?
Do you want to take this, or I can start?
I was going to validate that I understood the question correctly. So yeah, if you want to go ahead.
So my understanding is that you have a complex environment that you want to orchestrate. What would be the best way to orchestrate it?
Yeah, just like if you have multiple dependencies that like your test would require to like iterate through, right?
But there's
like not just like a standard like HTTP REST, response that you're expecting back. If you want to do like a full end-to-end, if you will, integration test, is that really what this is for? Or is it for like smaller tests that might be like, can I get the expected response in an HTTP or Kafka event, consumption, et cetera?
So of course, the more the environment grows in complexity, the more piping you will need to build in test container, because you will need to define which are the services and how they are piped. So the advantage of using test container is to take a look closer to some iteration, to some section, if you like, of your complete architecture. But if you try to replicate all of the architecture, I don't know about the even if that really makes sense, because at that point you will need to have a pretty good knowledge of the full environment. Mainly if you also put in things like toxic proxy and want to test also like the different network path that can happen over there. So I think there has to be a moment where this is a great way to do certain tests and focus on aspect of using environment that are as close as possible to production. But if you are going to simulate exactly a production environment, I don't think that that is gonna be necessarily something easy to do. I don't know if you are going to reduce the complexity. So the idea over here is that you have tools that are easy to start, like you don't have to take care of all the maintenance around the database, all the piping that you need to do. But if you start to have an environment that is particularly complex, then your activity will have been spent a lot in orchestrating, even like when does this start respect to the other one? Like, you understand where I'm going, correct?
Like it's not a technical limitation, but maybe a practical one. Like at what point is it a diminishing return on investment? Where,
that's the kind of the part that I was like trying to understand. Like, I don't think this crosses the chasm of like eliminating the need for certain, non-prod environments, right? Like that's not the goal here. The goal is to do small iterable tests. Otherwise, you're going to need an entire AWS region to run your test container. Okay, that helps.
But there's no limit. There's no limitation from test containers saying, you can only have one object per class that is managed, right? Like that. So you can, or as Swale is pointing out, right? If you had been doing something in a Docker Compose before, then that is also supported, whether you rewrite it as a test with multiple containers or whether you simply use the Docker Compose module to recreate what you were doing before.
I see that there is also a comment on this from Swale in the chat. And yes, Cora is essentially you and him are saying the same thing. Like you can use a Docker Compose script.
Okay.
I guess if it makes sense to write it, like I think you apply the approach that you would normally to writing your integration tests in your code, right? So if your test in your code starts to get so complex that it doesn't make sense as a test, regardless of whether you're using test containers or not, then it probably doesn't make sense to kind of pack all of that testing into, right?
Yeah, I'm just trying to like differentiate in my head where like when does it make sense to do something like mocking a complete API outside of like a test that is run at compile time versus like this, right? So I'm just trying to understand like when it would make, you know what I mean?
Yes, there are few things. So one, and like the example that Cora gave around, look at the dialect is different. And you don't want to fail if you don't have to fail. So if you use something that is like H2, the in-memory database, you're going to fail when you don't need to fail. Mocking is great when you need to test logic of things. But if you also have a state, for example, you are running migration scripts, it's going to be really hard to run that using mocking. But what you can do is that you can instantiate a database with some preloaded context, test your migration script over there and see what happened. Like now, when you do code first, for example, approach from code first for this, failing fast in your own environment. So the idea is that this will give you the possibility to focus in on a specific target, verify that in your environment before you go to the real big test environment with all of the bells and whistles.
Yeah, I'd also add that I think there's, there's like mocking things is sort of a thing we do because we can't test against a real thing, right? So, and it involves effort. So I think even if you think about things like Spring Cloud Contract that try to automate a little bit and introduce a little bit more reliability and sort of consistency between the producer and the consumer, even though they may be separate teams. So if you're kind of trying to find ways to minimize mocking so that you have more affinity to the thing that you're actually testing against, and also in that case, you could take something like a stub jar file that's actually produced automatically generated by something like Spring Cloud Contract, and run that as a container that you test against. So you could still leverage, that would be, you could run it mock, but then let's say you want to do toxic proxy against that, right? You could, that could be the thing that's running your container as well, right? So I think generally
that was actually one of the use cases that came up in my head, was like using like something like Swagger code gen or something like that to leverage, like to build out as part of your container. That's, yeah. I'm glad you said that, because that kind of validates that idea. Yeah. Okay, cool. The other question I had was actually on is it toxic proxy? Is that how you say it? Okay.
Yes.
So are you able to invoke like when it comes to if you want to do latency, like a latency test, right? So different out of the box, like Spring Kafka, for example, libraries have behavior based upon when there's latency between a given producer and let's say just like a Kafka broker, different exception handling will happen, right? Like producer exceptions will come, etc. So are you able to, with like proxy, invoke latency at like a component level, or like even at like a specific like TCP socket or anything like that, or any kind of socket? Like, is that like a feature?
So as you can see, you can map toxic proxy with a specific port for a container. So you have this, like you can do this at the channel level.
Got it. So short answer, yes.
Yes.
Okay.
Yes.
Got it. Thank you.
Welcome.